Alright, we're going to work on solving systems of inequalities today. So just in general, when you're graphing a system of linear inequalities, we're just going to graph lines today, you're going to find the shaded region that satisfies each of the inequalities in the system. And feel free to pause this because I cheated and I already wrote that down. But we're going to find the region of the graph that's going to work for all the inequalities that we have in our system. Okay, so what I want to remind you of first here is pay attention to whether the line should be solid or dotted and whether we should shade above or below. So the first inequality I have in the system underneath here just says y is greater than, so I'm just going to make a note for myself that that's going to be a dashed or dotted line. So the points along that line will not be part of our solution, and greater than y by itself is going to be shade above. And I'm going to go ahead and put that on the graph. Just while I'm doing this, I'm going to go, my y-intercept there is -1. We're just going to go down 1 over 1, down 1 over 1. Alright, and I'm just going to kind of do my best to use a dotted line. If you guys have a ruler or folder and you want to make it a little more straight, mine looks kind of bad there, but we'll get over it. Alright, now, my second inequality, I'm not on the screen, sorry guys. My second inequality is not in slope-intercept form, so let me just do that real quick. I'm going to subtract 2x from both sides. And I'm just going to slide the 9 down so I can put that -2x right after the inequality symbol. And I am going to end up dividing by a negative here to get y totally alone. So I've got to remember that that's going to flip the sign over. I'm going to go ahead and leave that as a fraction, but the two negatives will cancel each other out. So we'll have positive 2/3 x, and then 9 divided by -3 is -3. Okay, now I'm going to write down, this should be a dashed line or dotted line. Also, y is less than, I'm going to shade below for this line here. Okay, so I'm going to come over to my graph. I'm going to go down to -3. And then I'm going to go up 2 over 3, up 2 over 3. And I think I counted that right. So, dashed line here again. And these don't intersect at a nice point, and that's okay though. We're looking for all the points that satisfy both. Okay, so for my first inequality, I'm going to shade above. Now, if you want to do this sometimes I just don't even do this, but it would be up here to shade above. And to shade below this line, just going to kind of lightly be below here. And what I'm looking for is the overlap, which would be this region right here. So all these points will work for both of those inequalities. I am less than the line that I drew in pink, but greater than the line that I drew in purple. Okay, and I'm going to try one more here. So the first inequality, y is greater than or equal to, so solid line, and I'm going to shade above that. We're going to start at -6, and the slope is negative, whoa, let me put it on the graph so you can see it. Slope is -1/2. So I'm going to go down 1 over 2, down 1 over 2. I could also go backwards. I could go up 1 over 2 to the left. And I'm going to do my best to make a solid line there. And I'll be shading above that. So maybe I'll just lightly kind of remind myself where that would be. Now the other inequality, again, I'm going to do the same thing I did on the last question. I'm going to get that in slope-intercept form. So I'm going to have 2y, just slide that 10 down, -6x plus 10, everybody gets divided by 2, and I'm going to have y is less than -3x plus 5. So we're going to start this guy up at 5, go down 3 over 1, down 3 over 1. This is going to be a dashed line here, and I didn't flip my sign because I did not divide by a negative. I just subtracted the 6x divided by a +2, so this is going to be a less than. So I would shade, once I get this drawn in here with my little dotted line, I'm going to shade below. And So if I was looking for the overlap here that's going to work for both, it's going to go kind of in between here. And so all these points would work as our solution to our system. And sorry, I totally didn't do this on the last question. What you're looking for here is at the bottom, it just says give an example of a solution. Literally, you could just grab yourself any point that falls in the shaded region. Everybody could have a different example. One possible example for mine, I think I marked on here, this is 6, -2. That'll work in that situation. This one over here, the one I just randomly marked, I marked -2, -1. So just give an example in the shaded area is all you'd have to do to tell me a possible solution. All right, down here at the bottom of the page, just going to practice some vertexal and horizontal lines. So this is a nice vertexal line. X is greater than or equal to 2. So solid line here, and this above and below does not work if it's a vertical line, so you got to think about it for a second. Where are your x values bigger than 2? Well, we're going to go to the right to kind of represent that. So the shading would be going that way. And just a plain x is less than, so a dashed line, -3. So I'm going to do a nice vertexal line where all these x coordinates are -3. And less than -3 would go to the left side if I've got a vertical line like that. Now, you guys will notice I just barely shaded there. The overlap does not exist here. I cannot have an x coordinate at the same time that's bigger than or equal to 2 or less than -3. It's not possible. So this is actually no solution because there's no overlap there, excuse me, to the shading. All right, now the other one, we've got a horizontal line, so I'm just going to do dash line at 5. All these y coordinates are 5. And less than, I'm going to shade below. So less than would go, I'm just going to lightly do that below there. And x is greater than or equal to 0. So that's actually the equation of the y-axis, because all these x values on this vertexal line are 0. And greater than or equal to, that's why it's a solid line, so solid line. And on that one, greater than, I'm going to shade to the right of that. Okay, so then my overlap, I need a y-coordinate that's smaller than 5, but an x-coordinate that's bigger than 0, or equal to 0, so all those points will work on the y-axis. But this would be your overlap, this kind of quadrant right here. And all those points would satisfy my y-coordinates less than 5, but my x-coordinate is greater than or equal to 0. Okay, a little review of some absolute value graphs for example 3 here. So we're going to solve the system. It's just going to look a little different than the ones on the front because we're going to graph some absolute value. So if I see that absolute value, I know I'm going to have that V shape. And for that first one, I'm just going to write this underneath here so I have a little bit more space. If you guys remember, to find the vertex, you want to do opposite copy. Whatever is inside with the x is going to be the opposite of what that looks like. It's what that sets equal to 0, where it switches from one side of the V to the other. So I'm going to use +2 as my x-coordinate. That's going to shift it 2 to the right from the origin. And this +4 is going to move it up 4. So I'm just going to copy that right down. The little negative out in front, I'm just going to write down that my slope is going to be -1. So what you want to do is we want to plot this point 2, 4. And then on either side, because of the negative, I know it's going to turn upside down. I'm just going to go down 1 over 1 on either side to create that V shape. And this is going to be greater than this, so I'm going to shade on top of it when I do it, but for the moment I'm just going to do a little dash line. We would greater than would shade on top of this, and so it would be all those points. But I got to satisfy my system, so I got to work for both. Okay, now the next inequality, I've got y is less than or equal to 3 over 2, and then in absolute value x plus 3 minus 7. So opposite, what would set that equal to 0? That's where it switches from one side of the V to the other. So opposite, it's going to be negative 3 there would set that equal to 0. Copy. So this from the origin is going to shift 3 to the left and down 7. And then out in front here, I actually have a stretch. This will be a little bit more narrow of a V shape when we just created 3 over 2 because it's bigger than 1. So I'm putting that in quotation marks because technically one side's positive and one side's negative when you do the V shape. But if I find that vertex, I can just go up 3 over 2 on either side. So let's find the vertex first. So negative 3, negative 7. And then I'm going to go up 1, 2, 3 over 2, up 1, 2, 3 over 2 this way. And if I want to repeat that, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. This is going to be a solid line here because it's less than or equal to. Okay, now I will tell you the shading on this is a little bit weird. So I have to be greater than the one I have in my pink pen, and I have to be at the same time less than the one that I have in my purple. So to do that, this is weird. The overlap here above the pink line but below the purple be right here. All these points. But also you've got another area. Remember, I'm trying to be above the pink but below the purple. You actually have another area, another region over here. And I know I'm way off the graph, but there are all those points would work for both of those. So that one's kind of a weird example, but it's a good one to look at. We're satisfying both inequalities. I'm less than the purple, but greater than the pink. Okay, this says radio station is giving away tickets to a play. Plan to give away tickets for seats that cost $5 and $10. And they want to give away at least 25 of the $5 tickets. The total cost of all the tickets they give away can't be more than $300. Okay, so let's just so we all have the same thing. Let's let X be the number of $5 tickets and Y to be $10 tickets. Okay, now, in terms of the money, it says they can give away no more than $300. So every $5 ticket is $5. Every $10 ticket is $10. So I'm just going to attach those to the variables. And I have $300 to spend. Sorry, I'm getting kind of close there to that graph. Now, it says they want to give away at least 25 of the $5 tickets. Now, this is very tricky, but you don't want to use the $5 amount when you write this inequality. So I just nothing to do with the monetary value, just I want to give away 25 of those $5 tickets. X just represents a $25 ticket. Don't worry about the cost, and I want to give away at least, so greater than or equal to 25 of those. So that's what my set of inequalities would look like there. Now, for this particular problem, I would not recommend getting that first inequality in slope-intercept form, only because as I look at that, I know 300 is divisible by both 5 and 10 pretty easily, so I'm just going to do intercepts with that. So if you just go ahead and divide 300 by 5, you're going to end up with 60. So the x-intercept there will just be 60. And if I divide 300 by 10, that'll be 30. And we can just do our best to play connect the dots here. Okay, now I need to be less than or equal to this, so I need to be below this lovely line here. Now, my other constriction is that I want to give away at least 25 of the $5 tickets, so looks like our x-axis here goes by 5, so 25 would be right there, so I'm going to draw a nice vertexal line there. and I want to be greater than that, so I would go to the right. So less than the purple line and greater than the pink line. And I'm going to try my best not to color outside of the first quadrant, because that would mean we're selling a negative number of tickets, which we're not going to do. So we're just going to have this little region right in here. And you can use any point in that region to give an example. So possible example, I could just use my x-intercept, 60, 0. That means I would give away 60 of the $5 tickets. I could pick any point that comes in here. So I could do like 35 and 5. That would make me spend under $300, but give away at least 25 of the $5 tickets. So just any point in there would give you an example for that situation. And one last problem here. This is really just adding an additional inequality to the system. So this system actually has 3 inequalities. So we need our shading to work for all 3. So that very first one, horizontal line at -2. And that's going to be a solid line, and I'm just going to lightly shade above that. Second equation is -2x plus 7. So I'm going to start that at 7, slope down 2 over 1, down 2 over 1. And this is going to be a less than, so this is going to be a dotted line here. Less than goes below, so shade that way. And then I've got one more, which is y is less than or equal to 4/3 x plus 1. So let's find 1. Then I'm going to go up 1, 2, 3, 4, and over 1, 2, 3. This guy should be a solid line. And this one is also a less than. So I don't know if you guys were paying attention as I was going through, but I'm looking for a region that works for all 3. And it's actually going to be this little kind of triangle area here. All these points will satisfy that entire system. They work for all 3 of those inequalities. Just a little added challenge there, extra inequality.